Whoa, dude, this series is so awesome. I know that's what you guys are thinking, and let me tell you, you're right, because in this video, we're going to be talking about how to create even more awesome variables. So yeah, you've seen, hey, we can make a string, wow, that's fun, but now we're going to be talking about what are known as primitive types. It's basically a fancy word just to say more variables. Alright, so far we've talked about creating string variables and how to create them using this string constructor, as well as this more sexy syntax right here. But you know, we're obviously going to need more than just strings, right? We can't build a whole application with just words. We need numbers, we need dates, we need more complex objects and all kinds of stuff. So this just requires me to go in a little bit more depth with Java data types. So what the crap is a data type? So a data type is basically real helpful, the type of the data. How the computer interprets the data. Alright, so for example, we could have the value 5 and then we could have the value 5. These are two different things, right? So this is a number and this is a string. Yeah, they're trying to represent the same thing, but the way the computer interprets it is different, right? So if you use this, the computer thinks, hey, this is a number. This can be added. This can be subtracted from. Well, if you use this, it's a string. So hey, we can concatenate to this string and add content in this string, but we can't use it for math, right? So even though we're using the same number here, the data type itself is different. Java is known as a statically typed programming language. And what that means is we need to say what type our variables are up front. So we say, yo Java, we're going to store a string value in this variable. So we basically need to say the type of all of our variables up front. And basically Java is just saying, yo dude, in order for me to best work with your variables, I need to know what type they are. And with that, you need to define all of the types up front before we even compile. This is in contrast to different programming languages such as JavaScript, for example, which by the way is not related to Java in any way. In JavaScript, variables do not have types. They can store anything. That is not the case in Java. You can only store a string inside of this string variable. So that means if I go down here and say string equals 5, well, guess what? We're going to get an error. And it's going to say, bro, you need to change the type from string to int. So once you define the type of a variable, it's permanently that type. So yeah, that means we have statically typed, which means all data types up front before compiling. And in contrast, we have dynamically typed. And this means variables do not have types. And for statically typed, I should probably say variables are given data types up front. Okay, so I admit I kind of went off on a tangent. It's really not what I wanted to talk about in this video, but that is useful information. What I wanted to talk about is just the way we can break up different data types. So there's actually different categories of data types. And you know guys, anytime you can categorize things, this is really good because it helps you memorize things. Which is why I categorize languages into statically typed and dynamically typed. There are primitive types, and then there are objects. Anytime we call a constructor like this, or anytime we use a string with this fancy syntax here where we don't need that constructor, we are creating an object. So somewhere there's defined this string class that defines the way a string works. And what we're saying is, hey, we like this implementation. We want to make an instance of this blueprint that you're defining in this string class. And we're going to name it easier. So an object is just an instance of a class. And the class is the data type, by the way, just for clarity. So in this case, string is the data type. It's also the class name. For primitive types, there's a limited number of possibilities. When we're talking about objects, well, hey, there are tons of classes out there, and anyone can create their own classes, so there's essentially unlimited object types. So here are the 8 primitive types. We have Boolean, byte, char or car, short. For some reason I was thinking short, which doesn't even make sense. Int, long, float, and double. All these tell Java to treat the data in different ways, and we're going to get into these types and how to use them, but now I just want to look at data types from a conceptual view. So when we create a primitive type, the way we create it is different. So we do not do this new stuff here. We don't do that. So for example, if I wanted to make an integer, all I would say is int x, and then I use the assignment operator and give it a value. So this is how we create a primitive. Now, for every primitive type, there is a way to create an object similar to this type. And this is what's kind of confusing, but I'm just going to get over this right at the beginning. So we can create an object version of the integer using a capital I and spelling out integer, and giving it an identifier, and then assigning a value to it. So you could assign a value to it just like this as well. You're not always going to be able to do that, but for strings here you can, and for these primitives you can, because this is basically going to be, this value is going to be converted to an object. Okay, so this is an object. And by the way, that conversion to an object is called autoboxing. Okay, so what in the world is going on? Why do we have a primitive type and a class type? Well, sometimes you're going to need to use the primitive, and then other times you're going to need to use an object created from the integer class. 99% of the time we're going to use these primitive values, but just so you know, there is a class equivalent, and the way these work are fundamentally different, and that is something we're going to get into throughout this series, and that is how primitive values are different than object values. In general, we can use them in the same way, so I can come down here, I can print x, I can print y, and it should work. Yep, they both print 5. Nothing out of the ordinary here. The difference between primitives and objects really shows up more when we're passing data around to other variables or as arguments to methods, and you'll see that when we get to it. So I'm just going to clean this up here. That covers everything I wanted to talk about in this video, so now you should have a pretty good understanding of the primitive types as well as how they're created in comparison to objects. So at this point, consider you're learning the Lego pieces of a Lego set, and eventually you're going to start being able to put these Lego pieces together to build, like, you know, some crazy spaceship or something. So stick with it. Don't quit. I know this stuff can be a little, what's the word? Boring. But trust me, it gets funner. Alright, I'll catch you guys in the next video.